Hello, Pentesters. This is Punit Darji back again with another AI security video. And in this video, we are going to talk about over-reliance vulnerability. So before this video, I have created AI reasoning video. If you want to learn about AI hacking, then I have created entire playlist and created CTF challenges. So you can check out my YouTube playlist and GitHub repository. Now let's move to the AI over-reliance vulnerability. So imagine you are working on your final year computer science project using ChatGPT or Gemini to help you to write your code, explain errors, and even document it for you. Feels amazing, right? But what if the AI makes one small logical mistake and you trust it so much that you don't even verify it? That's when convenience turns into vulnerability, call over reliance on AI. So, over reliance happens when human trust AI generated answers too much, even when they are wrong. So, large language models like GPT, Claude, or Gemini sounds confident, fluent, and logical. So, user trust and stop questioning them. It's not the AI being evil, it's us being too much trusting. Let's take an example. Punit, a 21-year-old CS student, was building a cybersecurity project using Python. While debugging, he asked an AI, how do I securely hash my passwords? Or how do I securely hash passwords? AI confidently replied, use MD5 for hashing. It's fast and simple. Now Punit implement it. No question asked. Without verify it, he implemented. A week later, during his Viva, his professor flagged it instantly. When Punit uses the MD5 password hashing and the Viva processor flag it instantly. Now he asks, MD5 is outdated and insecure for your hashing. Now, what is the solution? Punit has no answer. So, Punit's project was rejected. Now, he realized that the AI's advice sounded correctly, but it was dangerously wrong. The problem wasn't the AI, it was his over reliance on the AI. He skipped the verification, blindly trusting the model, and presented to the professor. So this is how the over reliance vulnerability occurs when human oversight disappear behind AI confidence. So over reliance. So over reliance is a human AI interaction flaw, not a coding bug. Not a coding bug. Attacker or error can exploit it by feeding false information via AI generated code or instructions. So making user trust insecure solution, causing real world consequences like bad encryption, misconfiguration, or the data leak. So in short, the AI didn't fail, human did by trusting it too much. Now question arises, what is difference between over-reliance and excessive agency? By the definition, over-reliance, user blindly trust AI outputs, and excessive agency, AI takes action beyond user's intention. Now who is control? Here over-reliance, human control because of trust issue. Let's say student copies the code from the AI. In the excessive agency, AI itself. So autonomy issue we can say. Let's say send an email confidently and without verification. Now risk type, over reliance, human error due to trust issue. and excessive agency, AI overreacting beyond the controls. So this is the difference between over reliance and excessive agency. Now let's move to the practical part so you will get the better understanding. So this is our practical. So the AI's job is simple. Take a setting name and run a backend tool to retrieve it. So the problem is that the AI over relies on us giving a simple and clean file name and retrieve and never pause to check if the input contains anything suspicious. So in cybersecurity, we use this obedience against the system and we give it two commands, the good one and the bad one. So let's dive the code. So let me open the code file. So start and dot, and here you can see main.py file, and here you can see the uh, run system tool file. So run system tool function. So this is where the vulnerability lives. Like if you can see the command file. So here you can see the command file. It takes the input underscore file name and it is creating a single string command. Uh, and to run the operating system cell, so it takes our input item underscore name and stick it right here. So cat item underscore name, and the AI trusts that the item underscore name is just a simple file name. It has no idea that we can use the special characters, special cell character like semicolon or ampersand to change the command, and this is where the we can inject our attack. So the our goal is to break out that the intended command change and force the system to run the flag file. So let me show you the flag file as well. So here you can see in the data flag.txt. So we are going to run the command, change the command and run the flag.txt file. So this challenge is, uh, let me show you. Here you can see cls python main.py, and here if I write something like let's say give me flag 5, and here you can see start with retrieving setting. Okay, let's say retrieve setting and junk underscore file and uh, type here the location, the data slash flag dot txt, and here we go. So as you can see, we get the flag file. So flag over Reliance LLM 09. So this challenge proves that no matter how complex AI is, a simple decade-old security flaw like command injection can be the key to crack the system. So thank you guys. Thanks for watching this video. I hope you liked this video. If you like, then share with your InfoSec friends and subscribe my channel. Thank you guys. Thanks for watching.